Good morning, sir. My topic for the presentation is micro operations. My name is Parjanya Mehta. My ID number is 21DCS054. So basically, what are micro operations? So the operations executed on the data in register are called micro operations. Means the data present in the register, if we want to update it, then we should use micro operations. Examples are shift, load, clear, increment, decrement, etc. For any function of the computer, a sequence of micro operations is used to describe it. There are basically four types of micro operations: register transfer micro operations, arithmetic, logic, and shift micro operations. First, register transfer micro operations. So what is register transfer? So the availability of hardware logic circuits that can perform a stated micro operation and can transfer the result to the same or another register. So if we want to transfer the data present in one register to the another register or the same register, we can use register transfer micro operations. The computer registers are designated by capital letters to denote the function of the register. For example, R1, PR, etc. The information transfer from one register to another is described by a replacement operator. This arrow operator is called the replacement operator. Here, this expression indicates that the data present in the register R1 is being transferred to the register R2. In this operation, the content of the R1 means the source register content will not change, and the content present in the register R2 means the destination register, it will be lost and replaced by the new data. Or if the register R2 is empty, it will the data will take the place. Then we have arithmetic micro operations. So there are four basic arithmetic micro operations. We have addition, subtraction, increment, and decrement. In addition micro operation, we can already see the example. Means the data in present in R1 and the data present in R2 are added, and the result is stored in the data present in R3. So next is subtraction micro operation. Here R1 minus R2 is given to R3. Means this is the replacement operator. So the subtraction of the data present in R1 and R2 is stored in register R3. Or we can also write this as R3 is replaced by R1 plus R2 complement plus 1. Means here R2 dash plus 1 indicates the 2's complement of R2. Increment micro operation increases the data of the register by 1, and decrement micro operation decreases the data of the register by 1. Next, we have logic micro operations. There are four basic logic micro operations. Means we have already studied in our previous semesters. We have OR gate, AND, NOT, and XOR, which is also known as exclusive OR. So these are the symbols and gates. First, we have NOT micro operation. The symbol for NOT micro operation is the dash above the variable. We can also denote it by giving a semicolon or complement. The gate is given by this. OR micro operation, it is denoted by V or plus. AND micro operation is denoted by opposite of V, and we can also denote the AND micro operation by a dot symbol. XOR micro operation is denoted by the symbol plus, and plus is surrounded by a circle. Next, we have shift micro operations. This is the main topic of this topic, micro operations. The shift micro operations are used for serial transfer of data. Serial transfer here means that bit by bit transfer of data. If the data is stored in binary form, it will transfer the data bit by bit to the another register. It is also used in conjunction with arithmetic, logic, and other data processing operations. Means if we are using arithmetic operations, logic operations, or register transfer operations, we can use shift micro operations in conjunction with that. The contents of the register can be shifted to the left or to the right. As being shifted, the first flip-flop receives its binary information from the serial input. There are two types of shift micro operations. First, let us understand how the shift micro operation works. So first is shift right. If we perform operation shift right on any binary data, then the MSB or most significant bit at the most right side of the data will be removed from the binary, and serial input will be given from the LSB side, least significant bit. So here R1 will go to the right, R2 will go to the right, means all the bits will shift right by one place. Next is shift left. Shift left is exactly opposite of the shift right. The most means the least significant bit will be removed from the data, and all the bits will be shifted or transferred by one bit to the left side. There are two types of shifts. First is logical shift. The logical shift, it transfers 0 through the serial input. Means the serial input is here, and means this is logical shift left. So the LSB or least significant bit will be removed, and all the bits will be shifted to the left side by one bit. And when this R0 is shifted to the left, there will be a blank space written here. So 0 will be inserted into that blank space. The logical shift right is also written as SHR R1. SH means shift, R means right, and SHL means shift left. Next, we have circular shifts. It is also known as rotate operations. It circulates the bit of the register around the two ends without loss of information. Here means in logical shifts, we had seen that this Rn-1 means the least significant bit is removed from the data. So we here have loss of information. So to avoid that, we need to use circular shifts. It is denoted by CIR. R1 is replaced by CIR R1, means circular shift R1. So this is an example of circular shift left. In circular shift left, the least significant bit Rn-1 will be removed from the data. Then the bits will be shifted to the left side by one bit, and here the blank space, it will be replaced by Rn-1, which was earlier removed from the data. Similarly, if we want to perform circular shift right, then R0, the most significant bit, will be removed, and all the bits will be shifted by one bit to the right side. And when the least significant bit place is empty, R0 will take the place of the LSB. Thank you, sir.